Today we're going to be doing the tests for positive ions. So I'm going to separate them into the transition metals and non-transition metals. And the first thing we're going to do is we're going to use sodium hydroxide to form a precipitation reaction. As a reminder, a precipitation reaction is when we take two aqueous reactants. They will react together and one of the products will be insoluble. So the insoluble will precipitate and we will make a solid. So the one I'm going to start with is aluminium sulfate. So we are testing for the aluminium ion. So I put a small amount into a test tube. What I'm now going to do is add some sodium hydroxide, and we get a white precipitate. So you can see that it's kind of like a gel-like substance. Next we can do magnesium chloride. So this time we're going to be testing for the magnesium, which is a group 2 metal. So put a small amount in, put some sodium hydroxide in, and again we get a white precipitate. The third and final test, we can go for calcium chloride. So again, we are actually only testing the calcium ion, which is Ca2+, another group 2 metal. We put our sodium hydroxide and we get a white precipitate. So the different intensities is due to the concentrations. The magnesium chloride is a lower concentration than calcium chloride. But we have a white precipitate in all three, which is not surprising as they are not transition metals, so they produce white salts and colourless solutions. One difference is due to the aluminium, due to one of its properties. If we keep adding the sodium hydroxide, hopefully if I've got a high enough concentration, as you can see the precipitation is actually reducing. So if I mix this a bit, so if you now see the precipitation has redissolved on adding excess sodium hydroxide. If we add excess sodium hydroxide to the other two, you can see that they are not changing. So on adding the sodium hydroxide to the aluminium, we get a white precipitate. On adding an excess sodium hydroxide, it redissolves the precipitate. For the magnesium and calcium, they both produce a white precipitate that does not dissolve in excess sodium hydroxide. You would have to perform the flame test to further identify these ions. If we now go to the transition metals, we're going to start with copper 2. So I have copper chloride is a blue solution. So again, I'm going to add my sodium hydroxide, and this time we've got a nice light blue precipitate. We now have iron 2 sulfate. So iron 2 is Fe2+ because each ion has lost 2 electrons. So we're going to carefully add our sodium hydroxide, and it goes a light brown colour, and if we leave that will slowly turn brown. So it actually starts green and then goes brown. So if we add far in excess, it would go brown. If we added enough, it would have started green. That's quite a difficult one to see. If we go to iron 3, so that's Fe3+, the iron has lost 3 electrons. We'll put our iron chloride in our test tube. And now we add our sodium hydroxide. Again, we're going to carefully watch it. So this time we will make there we go. So it's a reddy brown solid precipitate. So I think there was some acid in that iron chloride bottle just to keep it, so that's why we had to put 2 put more sodium hydroxide in, but the sodium hydroxide test gives us this nice red-brown precipitate. We can still see that this is still going darker. It did start green, but it is going more and more brown. So to recap, our aluminium, magnesium and chloride, aluminium, magnesium and calcium, they all produced a white precipitate when we added sodium hydroxide. Further addition of sodium hydroxide to the aluminium dissolved the precipitate. Our copper ion produced a light blue solid on the addition of sodium hydroxide. Our iron 2 ion produced a green solid which turned brown on the addition of sodium hydroxide. And finally, the iron 3 produced a red-brown solid when we had that precipitate. So today we're going to do tests for the positive ions, and the positive ion test we're going to do today is the flame test. The flame test will just effectively check for the elements. It won't be able to distinguish between, say, copper 1 and copper 2, but it will tell us if the element is in there. So what I have is my Bunsen burner, and I'm going to set it to a roaring flame. That's going to give us our best chance of getting the colour we want. I have a nichrome wire. That nichrome wire will not react with anything. And I have some hydrochloric acid. The hydrochloric acid is simply there to help me wash my nichrome wire. The first flame test we're going to do, we clean it with the acid, and we are going to do the test for lithium. And you can see lithium makes that nice crimson flame. So lithium is our crimson flame. The next one we're going to do, so wash it again with our acid. And now we're going to do potassium. So potassium produces a lilac flame. It can be quite difficult to see, but we do have a lilac flame. The next one we're going to do is sodium. Again, so I'll clean it in the acid. So this is sodium, and it produces a nice yellow flame. The next one we're going to do is calcium. So calcium produces a vibrant orange-red flame. Clean it in my acid. And finally we are going to do the copper. So we have lithium with our crimson flame. We have sodium with our yellow flame. We have potassium with our lilac flame. We have calcium with our orange-red flame. And finally copper with our green flame. If we do not clean it with the acid, what happens is one of the flame colours will mask the other. So sodium has a very, very distinctive yellow colour. If we were to mix potassium and sodium, the potassium will be hidden by the sodium colour. So that's why we must use the hydrochloric acid to clean the wire between experiments.